All right. Looks like we got a little early Halloween treat. Okay. Minimum number of increments on subarrays to form a target array. Hard. All right, I'm going to give myself, let's say, a cap of 2 hours. I don't want to spend all night on this. Okay. You're given an integer array target. You have an integer array initial the same size as target with all elements initially 0. You have integer array initial the same size as target with all initial 0. Okay. If in one operation you choose any subarray from initial and increment each value by 1, return the minimum number of operations to form a target array from initial. You can choose any subarray. Interesting. The test cases are generated so that the answer fits in a 32-bit integer. Oh, okay. So this is kind of like a pyramid. So you want to increase all these by 1, and then increase all these by 1, and then increase all these by 1. So it'd be like increase this by 1, 2, 3, 4. And then this is 1, 2, 3, 4, 5, 6, and 7. Alright, well, this seems very understandable. So you can choose a subarray to increment. Honestly, this feels more like a medium than a hard. Yeah, this definitely feels more like a medium than a hard. It's early numbering, so maybe they would have made this in medium later on. Okay, so how to approach this? So I definitely can't sort it because sorting it would change the structure of the thing. I want to say this seems like a heap. No, not a heap. Seems like either like a queue, a monotonic queue, monotonic stack. So how would I approach something like this? 1, 2, 3, 2, 1. The subarray that has this 1 would extend as far as if the target has, well, does the target have a 0 at all? Target must have things at least 1. Interesting. The target is at least 1, then like the first subarray that you'd have would always be 1 across the whole array, because there's no reason why that would not work. Okay, but anyway, so you extend out that, and then everything here would become, in essence, 1, 2, 1. 1, 2, 3, 2, 1. So it would be pretty high acceptance rate. It would definitely be too slow to actually manually manipulate it down by 1 each. One, two, three, two, 1. Feels like a stack. Feels like a stack. So here 3 goes down to 1. 3 goes down to 1. There has to be 2 subarrays that are just one size to lower this down to 1. And then at that point, the 1 is the only thing that needs to be on the stack. 3 goes down to 1, so that's 2. 1's in the stack. Goes up to 5. Goes up to 5. I can probably get rid of the 1 because anything that could extend, any subarray that would be inclusive of 1 can extend past it, so 5 would be on the stack, and then the 4 would be on the stack, and then you'd have a 1. You add 1 to the answer. So you have a stack. Every time you decrease the value of the stack, then you would add the difference to your answer. 5 goes down to 4, 1 is added. 4 goes down to 2, 2 is added. So it's like 2, 5 to 4 is another 1, so it's 3, 4 to 2 is another 2, so that's 5, and then 2 to 0 is 2, so that's 7. 3 to 1 is 2, and 2 to 0 is 4. 1, 2, 3, 3 down to 2 is 1, 2 down to 1 is 1, 1 down to 0 is 0. Alright, let's see if that works. I think there might be edge cases that make it not work. We'll have a monotonic decreasing stack, which is a stack where you only add, actually is it even a stack? What if it's even a stack? For every value in the target array, maybe it's just the last value. The value is bigger than last, then last equals this value, else ants, if it's decreasing, then 5 to 4 is decreasing, then what? 5 to 4 to 2. Keep track of 5, 4, and 2. Guess. Maybe you just need to know. Maybe you just need to know when it decreases, actually. Huh. N equals the length of target for every n in range of, let's say, or every index in range of n minus 1, since I'm going to compare the current index value and the next index value. If 5 down to 4 down to 2, just capture when it goes down. If target at this index is greater than target at index plus 1, answer plus equals the difference. And that's it, and then you do need to return the answer plus the last, whatever the height of the last thing in the target is. I guess I don't need this variable. Let's see what test cases this is wrong on. Interesting. Well, it's not wrong. I guess this is just like more complicated solution solving or a more complicated approach. I guess the difference between this result and the other subject answers is optimization of what this means. If I'm just capturing where it goes down, I'm just capturing where it goes down. Is there a better way of doing that? 5. There's some logic there that I can just do without an if statement. Um, 3 to 1 is 2. And I can do something like this. I can just do the min of that and 0 maybe. Answer equals minimum or the maximum. Maximum of 0 and the difference. I don't think this is any better. There's some other logic that I should be doing here. Whoops. Doesn't even work. If it's bigger, this thing is bigger than this thing, then it's a positive. If it's a negative, then answer would that should add 0. I wonder what's going on here. 3. Let's go and print out the answer is after each loop. Okay, first loop is 0, second loop is 0. Oh, fuck me. It's plus equals. That's so sad. I'll stop the athlete shit. Okay, yeah. Let's not try that. Okay. So, what is the faster way of doing this calculation? Is there a list comprehension I'm missing? Is there a list comprehension that I'm missing? 70%. I mean, whoops, don't want to say that. 3 to 1, 5, 4, 2. This is 2, 5, 4, 2. So it's 2, and then like that eventually becomes 5. So it's 3. It's 3 minus 1, and it's 2 minus 0. Five. I guess 3 down to 1. 3 down to 1. 5. Yeah, I guess I could try to stack. Would stack be helpful here? So 5, 4, 2, 5, 4, 2. So the 4 really doesn't matter. 5, 4, 2. 4 doesn't matter because if it's just 5, then 2. I can append a 0 to this thing, and then I don't have to work into append like target append 0. So that's equivalent, really. And then I don't have to worry about the last being added. 5, 4, 2, 0. So if I keep track of the high, refresh the low. 4 is low, 2 is low, 0 is low. And then when the low gets beat, I don't know about that. 5, 4, 2, 3 to 1. Keep track of the high. It's 3, see a 1. See a 5. The 5 would pop. Well, I really don't know. Like, this seems so concise. I'm gonna run it one more time to see what the random variation is. I really wish I could turn this off. Like, I don't need to see that pop up every time. Well, random variation makes it possibly even slower than before, even if it's the exact same thing. I guess I did append a 0 here, actually. So it was actually this before, right? Adding the last to it. Oh. Okay. Never mind. It's the actual, maybe the first time was randomly faster than the other times. Randomly faster than what is expected. Man, if the target is bigger than, maybe there's a better formulation of what should be calculated here. Every time I see it decreasing, I increase the value by the difference. Three to 1 is 2. Anytime I see it increasing, I should just anytime I see it increasing, so like actually, so it's like 5, 1, 3, 2, 5, 1, 3, 2, then it would capture the 3 going down to 2. Yeah, it needs to actually add each time it goes down and not just skip, I think. I guess I could do a while loop. Well, the index. Yeah, like a while loop where it increments as long as it's going down. Interesting. Okay. Index equals 0. It's like current equals target 0. Let's say while true, maybe. We'll worry about other conditions later on. While true, I guess maybe it should be something like while index less than n, and heck, maybe index should be at 1, to be honest. And while it's decreasing. While it's decreasing, so that should mean target at this index is bigger than or equal to target at index minus 1. Target plus equals, or sorry, not target, index plus equals 1. So then it reaches the point, selects 3. So it's looking at, how should this be looking at? So while this thing, maybe it should be index minus 1. Index minus 1. No, it should be something like while, okay, let's rephrase this here. Index is less than n while, maybe less than n, while target at index is bigger than or equal to target at index plus 1. So target index is like 3 is bigger than the next one, which is 1. Then increment the index. And then 1 is bigger than 5 is the comparison, which is false. So 1 is put the value in the next. So that means that it should be now, increment. So index is at the last possible spot. Is at the smallest, is kind of at the lowest point of the descending values. So that should mean the answer should increment by the difference between whatever was previously and target this index. And then it should reset to whatever's the next one after this that makes this false. So current equals target at, well, maybe index should be incremented at this point. And then current equals target index. And there should be some sort of break here. I think there should be a break here if index equals n, then break. I think this might return answer plus target, last target. Oh, God. Holy shiznicks. What is, stop the recommendations. Just give me the option to stop. Oh my God. Every single time. Wow, that made it worse. Okay. I think I can still maybe I can simplify this a little bit. Target pen 0. That point. No, is it pending 0 or pending infinity? Might be pending infinity. I want to make sure that this is false at some point. So, or this is never false. Index less than or equal to. I think maybe I can get rid of this now. While true. I think maybe this should be while maybe index is less than n here. Index plus equals 1 here. And then I here. Current equals target index. I don't know if I actually need this. That does prevent this thing from going too far. I think that might be fine. Answer is going to equal. Answer might still need to equal plus target minus 2 here. And I need to close this leet. God, that's so annoying. I need to look up how to stop that. Alright, well, I gave up. Gave it a good shot. Got 2 ways of trying to do the same logic. I'm going to go back to the most simplified logic here. Oh. Alright, I think this still works. Don't need that. Alright, whatever. So summary. So the logic for determining the number of subarrays can be reduced to looking at when the values are decreasing in the array for any such time. Any time when it's decreasing, that amount of subarrays must be added to the answer. Let's say for example, let's say the array is 312. 3 to 1 is decrease of 2. So answer needs 2 subarrays. So like that particular subarray would be just from 0, 0, inclusive those indices, in order to capture the height of 3 that is above 1. And then at the end, 2 basically to 0, which is the implied height, ending height, would need 2 subarrays. So in effect, the subarrays would be like there's 4 of them. There's going to be a 0, 0. I'm not sure how to do the subarrays. Subarrays would be 0, 0, 0, 0. And then there'd be a subarray that is from 0 to 2, which captures the whole thing, and then a subarray from like 2 to 2. But it's basically just capture the decreases and you're good. So just use a for loop which iterates over the indices and compares the values at index and index plus 1. If it decreases, then increase the answer by that difference. Lastly, add the final value of the target array to the answer or the implied 0. Right. All right. Time complexity is going to be O of n plus however long it takes to try optimizations that end up not working, which in this case was at least O of 2n. Space complexity, this can be O of 1, since no extra memory needed besides some no extra memory needed, like, yeah. All right, cool beans.